All right, so what we're going to look at here is, this is a section 1.3, just kind of a side lesson here, about piecewise functions and their limits. Now, in the review, this question is from the review, and it looks like this. Make this a little bit bigger. But here is an example of the question from the review. Okay. And so what this is right here, g of x is composed of pieces of three different functions here. Okay. That's why they're called piecewise functions. It's a function g of x that's made up of pieces of other functions. Okay. Now these pieces are, so this graph g of x exhibits the behavior of the graph x cubed over this interval right here on this domain. So everything less than 0 is going to look like an x cubed function. Okay? But that's only up until 0, and not including either. See, because it's just less than, not including. Now, between 0 and 1 inclusive, the graph is going to look like x squared. Right? So what I'm going to do is I'm just going to graph this real roughly here. Okay, really roughly. So up to 0, we're going to have a graph that looks something like this. And I'm going to put an open circle there. Okay, because why an open circle? Because it's not equal to. It doesn't look like this at 0, it's just up to 0. So it's where an open circle comes in. Now, the x squared starts at 0 and goes to 1. So if we had 1 right here, I know that a parabola looks like this, right? Kind of has it's curved there. And of course the dot would be filled in there at the same spot. So it looks like you have an open circle and a filled circle at the same spot. So that means that it's continuous though, okay? When an open circle and a closed circle are at the same spot. So now this might look like an x cubed function, but it's not. This part right here is y equals x cubed. That's this part right here, and I'll just outline it in red. In green over here, this is y equals x squared. Get that? Now, the only other little funny part here is everything now greater than 1, anything greater than 1, and I should go back. I'm just going to go back here and put a solid circle at x equals 1, 1, okay? But everything greater than 1 looks like this right here. And you may not know, like I knew what these ones look like, you may not know what this one looks like. I do know that it's a parabola, and it's opening downward because the a value is negative 1. See that? But what you could do is, if you were allowed a graphing calculator at this point, you could graph it on the graphing calculator and see, which is no problem.
How would you do that?
Well, what you have to do is you have to, I'm going to clear all this stuff. Okay. What you actually have to do is you do have to graph the entire thing. Okay. As far as I know, you probably can specify the domain, but it's kind of a waste of time. So I would go negative x squared plus 2x plus 1. And you can type it in exactly as it's written, or you can just do it. Okay. So look at this is what the graph looks like. You see that? Now, if it looks like the graph goes through x equals 1, 1. That's what it looks like. So let's just check that out. Okay. Calculate a value. Let's put in x equals 1. And oh, sorry, it's x equals 2, not 1, 1. I guess there's the 1 there. This is 2. So do you see what we're looking at here, Sam? What we're looking at is, and I'm just going to clip this screen here for us so I can bring it into my document and we can work with it a bit. Oops. Copy, paste. Okay, so here it is. And so this is what we're looking at. Starts there, and it goes down there. So that's the part that we're interested in, right? Now, if we're just doing a rough sketch, Sam, 1, 2.5. Okay, about 2.5. That's all you need to worry about. So let's finish our little sketch here. I know it's kind of small, and not. It could have been bigger, but let's go. What color should we go? Yeah, and so we need to go to 2 on the y-axis, and that's where we start. It's an open circle because this is not or equal to, right? It's an open circle, and then it goes to about here, 2.5. And so it's a parabola that kind of continues like this, okay? So if we were to graph this function, it looks just like this over here. So it kind of looks to be continuous to 0 and continuous through to x equals 1, y equals 1. That's what it looks like. And then it's a jump here, right? There's a discontinuity here, and then it kind of comes down in this fashion. So that's what this g of x graph looks like. It's the collection of these three parts. Now, the actual question says, find the limits here of g of x, that's this piecewise function, as x approaches 0 from the left. There's a little negative sign there. So as x approaches 0 from the left, we're looking at, here's x is coming in from the left. It approaches, look at that. The graph approaches y equals what? 0. Because that's the value of the function there, right? So what about from the right side? Well, from the right side, it's coming in towards, x is coming in towards 1, and there you go. Looks like 0 as well. So of course, the limit of the function is the value of the function. It's a y value. All right. So you know the difference now between two-sided limits and one-sided limits, right? The two-sided limit, or the general limit, exists if the left-side limit and the right-side limit agree. And so do the left-side limit and the right-side limits agree here? Yes, they do. So this one is 0. Now what about from 1? This is where we need to take a look at 1. The limit as x approaches 1 from the left. Okay, I'm going to use red marker here now. As x approaches 1 from the left, okay, this function here looks like it approaches what? It approaches this green part of the function. It looks like it's approaching y equals 1, right? That's what it's approaching. When you get really, really, really close there, that's what it's approaching. Now this may or may not work. I'll try and grab that. And I'm going to cut it. Boo. Alright, that's what I want to do. Just going to copy that and make that a bit bigger. Alright, so we're looking at x approaches 1 now from the right side. So as x approaches 1 here from the right side, this graph is here, it's here, it's here. What does it seem to be approaching as we get super close to x equals 1? Yeah, 2. Okay, so we go back up there. And this one from the right side is 2. So what's the limit as x approaches 1? Does not exist. Why? Because this is 1 and this is 2. The left side limit is 1, the right side limit is 2. That is not the same. They're not the same number, so does not exist. You put D and E, I'll know what you mean. Gotcha? Okay, now I guess B says to sketch the graph, so it's great. I guess we already did that. And if it asks us where is G continuous, or sorry, discontinuous, well, it's at x equals 1. Because you can see an obvious jump gap there. Okay? Does that make sense?
Originally, I had to do this because